Hi, Algebra 2. Today we are going to be talking about asymptotes. We are learning 3 new functions and they all have an asymptote. And believe it or not, you have actually already seen what an asymptote is. An asymptote really is just a line that your curve is approaching. So if you take a look at this curve is starting to approach this horizontal green line here. And a line that a curve approaches as you move further away from 0 is what an asymptote really is. So if I think about moving further away from 0 along this curve, I'm going to start to flatten out and you start to become part of this green imaginary line here. Every horizontal line, remember, is y equals and then whatever the number is. So that is the number that we're looking for, is where does this imaginary green line cross the y-axis? Because remember, this is where it hits the y-axis here. For the vertical asymptote, I'm going to follow my curve as it moves away from 0, again, away from the x-axis or y-axis, and I could go on either side. But remember, when you're talking about your vertical asymptote, you're basically looking for the line that looks vertical, and you're looking for where it crosses the x-axis. So since it crosses the x-axis, this is part of the domain because it's going to be x equals and then wherever it winds up crossing. So the y, the horizontal asymptote, is part of the range, and the vertical asymptote, the x, is part of the domain, and that's just because of the axis that it winds up hitting. The first function we're going to talk about is a rational function. You guys already know rational functions. They are the ones that look like a fraction. And the real definition, of course, for a horizontal asymptote, and you have a vertical asymptote as well, right? So a horizontal asymptote is really just as the x approaches positive and negative infinity. So if you're looking here, as it goes to the left, right? Or as it goes to the right, so as it goes toward positive and negative infinity, what is the y approaching? So what is that y value that your line is really approaching? So again, you're looking right here. What is that y value here? That's really the definition. When you guys take calculus one day, you're going to learn a real limit, and the definition has to do with a limit. You kind of understand right now a limit is something that you can get close to, but you can't cross it, or you can't go past your limit, right? In real life, the word limit means the same thing, and that's what your limit really is in math as well. It's where are you getting close to, but you're not really going to pass it. So that's what you're looking for. There is a shortcut, though, and the shortcut for rational functions has to do with the coefficients and the degree. So if you have a fraction, and I'll make a little example on the side here, and it's a fraction where the degree of the numerator is bigger than the degree in the denominator, there is no horizontal asymptote, so you don't have to worry about it. So for example, if you had like x to the 4th in the numerator, but then you have just an x in the denominator, you're not going to have a horizontal asymptote because you can actually divide that. So there's no horizontal asymptote in this first case. The other shortcut is that if you have a degree in the denominator that's bigger, so let's say, I'll put my example over here. Let's say that I have a fraction and I've got like an x squared minus 4 in the denominator, and then in the numerator all I have is an x. Well, in this case, your denominator degree, remember your highest exponent, is larger, so my horizontal asymptote will always be y equals 0 every single time, okay? So again, if your denominator degree is bigger, you'll have y equals 0 as your asymptote. And then if the degrees are the same in the numerator and denominator, then you just take the leading coefficients and you make them a fraction, and that happens to be what your asymptote is, your horizontal asymptote. So for example, if this was, let's say I've got 2x minus 4. And my degrees have to be the same, so that means I also need something with an x in the denominator. So let me do 3x and plus 1. My horizontal asymptote, because the degrees are the same, they're both x's, they're not x squareds and x or whatever the case is. My horizontal asymptote is just this ratio, this fraction right here, 2/3. So I will get an answer of y, because it's horizontal, is equal to, and then 2/3 is going to be my asymptote, my horizontal asymptote. So those are 3 little tricks that will help you guys find it algebraically from the equation and not just looking at the actual picture. Vertical asymptotes are much easier. All you have to do is set the denominator equal to 0. So there's an example over here where you actually have a quadratic, x squared minus 25, over another quadratic. If I set my denominator equal to 0, that would be x squared minus 16 equal to 0. This is where all of your skills throughout the year come into play. Because in order to solve this, I could factor it, or I could add 16 to the other side and take the square root. So you have 2 choices. I'm going to factor this one. So again, x squared minus 16 is a difference of squares. So I get x minus 4 and x plus 4. This takes me back to last unit, right? And in order to solve this, I will set each of my factors equal to 0. So if I set each factor equal to 0, that means I'll have x minus 4 equals 0 and x plus 4 equals 0. You guys already know what the answer is going to be, I'm sure. And x plus 4 equals 0. So we are going to wind up with x equals, nope, let's get our 0 in there. We're going to wind up with x equals positive 4 and x equals negative 4. All right, and if you guys take a look at the diagram to the right, x equals, there we go, and x equals. If you guys look at the diagram at the right, where are the vertical asymptotes? I see a vertical asymptote here. There's an imaginary line here that the curve is approaching, and that happens to be at negative 4. And then there's also an imaginary line over here that your graph is approaching, and that is your 4. So I found the vertical asymptote by setting the denominator equal to 0. So rational functions have both asymptotes. You guys have started to graph exponential functions, and we just took a look at this last class. Exponential functions are literally, the word exponential means getting very, very large very, very quickly. So it starts off kind of flat and then it goes up really, really, really fast. Exponential functions do not have a vertical asymptote because it still gets wider and wider and wider as it increases. But it does have a horizontal asymptote. And the horizontal asymptote, the parent function is always on 0. So if I add, right, if I add to my exponential, it'll move it up. If I subtract, it'll move it down. And therefore, my horizontal asymptote is just what line did you move it up to, or what line did you move it down to. So if I add 3, well then my y value would be at 3. If I added 2, then my y value would be at 2. And we'll look at an example of that later on. We also just briefly got to what logarithmic functions are. These are the inverses of exponential. So they look very similar, but they are reflected over the y equals x line. So if exponential functions don't have a vertical asymptote, but they do have a horizontal asymptote, then logarithmics are the inverse, so they are opposite. They do not have a horizontal asymptote, but they do have a vertical. And again, the vertical is very similar. Log functions, you guys will always see the word log, so you'll know it's a log function. And think about it. If I want to move my vertical asymptote, that means I have to either go to the right, I have to pick up the whole picture and move to the right, or I have to pick up the whole picture and move to the left. So the only way that I can move right and left is if I've got some number on the inside of my parentheses that is going to move to the right or to the left. So that b value is now going to be changing to the right or left. And we'll look at an example right now. So first example, find the vertical asymptote. Remember, vertical asymptote, this is a rational function because it's a fraction. So if you guys look back, we found our vertical asymptotes by setting the denominator equal to 0. Go ahead and pause and see if you guys can find what the vertical asymptote might be, or asymptotes might be. So if I factor and set my factors equal to 0, this function actually has 2 vertical asymptotes. And I know that because the denominator has an x squared in it. So I know that I'll have 2 vertical asymptotes, not just one. And they happen to be at -3 and 7. For the second example, you guys can try graphing this in your calculator. But e to the x, it's an exponential function whenever you have an x in the exponent. So when you look at the exponent and there's an x, you know that you have an exponential function. And exponential functions, of course, every parent graph starts at 0. So if I add 5, that means that I have now moved my graph up 5. So if I've moved up 5, and remember this is horizontal, so it's y is equal to 5, because I've moved up 5. And I start on 0. For my third example, we want to find the vertical asymptote for the log of x minus 5 plus 2. Remember, vertical asymptotes only occur with logs. Logs don't have horizontal. Just like in number 2, this was an exponential function. They only have horizontal. They don't have vertical asymptotes. So since we know vertical asymptotes are x equals, I am only thinking about what might affect the x, which is this number inside the parentheses. The plus 2 tells me nothing. I do not care about the plus 2 because that is moving up and down. I want to look at the inside of the parentheses because that is a transformation left and right. Since it's minus 5, I am moving right 5. Remember, we start on 0. So if I move right 5, I am now going to be crossing the x-axis at 5. So my vertical asymptote would be 5. See you guys next class.